When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on Sci and Why, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. The impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the Heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration. The mysterious humming sound from the void. Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space, a discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth, but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shock waves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph. The Heliopause's shocking behavior. You know, the boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The Heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the Heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The Heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation?
Electronic confusion in the cosmic deep.
So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems. Surviving the impossible, technology beyond its limits. Voyager 1's instruments should have frozen solid years ago when NASA turned off their heaters to save power, yet they continue functioning perfectly in temperatures that would destroy any other spacecraft. Honestly, the laws of physics suggest Voyager 1 should have died long ago. As the spacecraft's plutonium power source gradually decays, NASA has had to shut down non-essential systems to conserve energy. In 2019, engineers made the tough decision to turn off the heaters that keep the scientific instruments warm in the -270°F environment of space. This should have been a death sentence for the delicate electronics, yet all 5 instruments continue operating flawlessly. NASA engineers are genuinely puzzled by this phenomenon, unable to explain how 1970s technology survives in conditions that would instantly destroy modern spacecraft. The instruments operate in temperatures hundreds of degrees below their design specifications, totally defying every engineering principle. Some scientists theorize that the instruments generate just enough internal heat from their electronic operations to prevent complete freezing, while others suggest that decades of cosmic radiation exposure may have altered the materials in unexpected ways. The spacecraft's resilience has actually forced engineers to reconsider fundamental assumptions about electronics in extreme environments. This unexpected durability has extended Voyager 1's mission far beyond anyone's wildest expectations, allowing it to keep transmitting data from the interstellar frontier where no human technology has ever ventured.
The cosmic radiation bombardment.
Beyond our solar system's protective shield, Voyager 1 faces a constant barrage of cosmic radiation that's, 3 times more intense than anything experienced within our cosmic neighborhood. Interstellar space has revealed itself to be a far more hostile environment than scientists ever anticipated. Once Voyager 1 crossed the Heliopause, it encountered cosmic radiation levels 3 times higher than those within our solar system's protective bubble. This intense radiation, consists of high-energy particles accelerated by distant supernova, black holes, and other extreme cosmic phenomena. These particles constantly bombard the spacecraft, gradually degrading its electronic systems and creating cumulative damage that just builds over time. The radiation can actually flip individual bits in computer memory, causing small errors that accumulate into much larger problems. It's honestly like trying to maintain a complex machine while it's being continuously sandblasted by invisible particles traveling at nearly the speed of light. Despite this constant assault, Voyager 1 systems continue functioning through a combination of robust 1970s engineering and clever software workarounds developed by NASA's engineers. The spacecraft's experience provides crucial data about the radiation environment that future interstellar missions will face. Understanding these conditions is essential for designing spacecraft capable of surviving the journey to nearby star systems. Voyager 1 has become humanity's first radiation scout, mapping the dangerous terrain that lies between the stars and providing invaluable information for future deep space exploration.
Software updates across the cosmic void.
NASA engineers regularly send software updates to Voyager 1 across 15 billion miles of space, basically providing tech support to a computer system that's actually older than most of the engineers working on it. Maintaining Voyager 1 requires honestly some of the most challenging technical support in human history. The spacecraft operates with 1970s computer systems programmed in assembly language, a low-level programming code that directly controls hardware components. When problems pop up, NASA engineers have to write new software instructions and transmit them across the vast emptiness of space, where radio signals take over 22 hours just to reach the spacecraft. The engineers use a mix of assembly language and pseudocode to create efficient programs that won't overwhelm the spacecraft's limited 70-kilobyte memory. Each software update has to be perfect. There's really no chance for quick fixes or patches when your target computer is billions of miles away. These updates have solved critical problems throughout the mission, from reactivating backup systems to working around failing components. In one case, a software update saved Voyager 1 from potential disaster by activating fail-safe mechanisms when a hardware component failed. The process requires engineers to think like programmers from the 1970s, using techniques and limitations that modern computer scientists rarely ever encounter. This cosmic tech support is, honestly, one of the most impressive examples of long-distance troubleshooting ever attempted, keeping humanity's most distant ambassador operational out in the depths of interstellar space.
Revolutionary discoveries that changed everything.
Voyager 1's journey revealed that Jupiter has 3 delicate rings. Saturn's rings contain thousands of intricate braids, and volcanoes exist on moons we once thought were totally dead, completely revolutionizing our understanding of the outer solar system. Before Voyager 1's grand tour, our knowledge of the outer planets was limited to fuzzy telescope images and just basic orbital mechanics. The spacecraft's close encounters showed us a solar system far more complex and dynamic than anyone had imagined. Jupiter, which we thought was a calm gas giant, turned out to be a world of extremes, with hundreds of violent storms, glowing auroras, and 3 previously unknown rings that are honestly more intricate than fine jewelry. Saturn's rings, once considered simple and few in number, revealed themselves as thousands of individual ringlets with braided structures that seemed to defy the laws of physics. Most shocking of all was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, erupting at temperatures just 40 degrees above absolute zero. These findings totally shattered the idea that volcanic activity was unique to Earth and the inner planets. Maybe most significantly, Voyager 1 identified potential habitats for life on Europa and Enceladus, moons harboring vast liquid oceans beneath their icy surfaces. These discoveries transformed our understanding of where life might exist in the universe, expanding the concept of habitable zones way beyond traditional planetary boundaries. The mission's revelations keep influencing space exploration today, inspiring missions to study these potentially life-bearing worlds in much greater detail.
The eternal journey into galactic immortality.
In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, carrying humanity's golden record message to any intelligent civilization that might find it. Voyager 1's scientific mission may end in the late 2020s when its power finally fails. But honestly, its journey through the galaxy is just beginning. The spacecraft will keep traveling through interstellar space for millions of years, eventually becoming an artifact of human civilization drifting among the stars. In about 300 years, it'll enter the Oort cloud, a spherical shell of comets surrounding our solar system. After 30,000 more years, it'll completely escape the sun's gravitational influence and start orbiting the center of the Milky Way galaxy alongside billions of stars. The golden record attached to Voyager 1 contains sounds, images, and greetings from Earth in 55 languages, serving as a cosmic message in a bottle for any intelligent beings who might encounter it. This record includes everything from Bach's music to whale songs, from mathematical formulas to images of human faces. The spacecraft has become humanity's first interstellar ambassador, carrying our story into the cosmic deep. Long after human civilization has evolved beyond recognition, Voyager 1 will continue its silent journey through the galaxy, a testament to human curiosity and our drive to explore the unknown. The mission represents more than scientific achievement. It really embodies humanity's eternal quest to understand our place in the universe and reach beyond the boundaries of our cosmic home. From mysterious cosmic humming to impossible electronic survival, Voyager 1's 47-year journey has shown that our universe is far stranger and more dynamic than we ever imagined. This brave little spacecraft keeps rewriting the textbooks of space science while carrying humanity's message to the stars. If you're fascinated by these incredible cosmic discoveries and want to explore more mind-bending space mysteries, go ahead and hit that like button, share your thoughts about Voyager's amazing journey in the comments, and subscribe to Sci and Y for more adventures into the unknown. Thanks for watching. Keep exploring the cosmos.